Now, let's look at, actually, we're going to take these piecewise functions and graph them now. Okay, now this is usually where it kind of gets a little bit difficult to do. So what I'll do is I'll kind of baby you through the first part of this by color coding it. So I think I asked you to get some graph paper, and if you wanted to get like a couple of different colored highlighters, and that kind of really helps you to see it. Now, you don't really have to use the highlighters every time you do one of these, but if you use the highlighters like the first couple of times when you see one, it really makes a difference in helping you understand that. Now, let's look at some examples now of how I can take a piecewise function and graph a piecewise function. All right, so let's start off with this one. All right, so we have f of x equals, and hang on, I'm going to screw it up just a minute. Let me scoot this over. Leave myself enough room over there. All right, so we say I have f of x equals, okay, so we'll make it just in two pieces here. So we're going to do negative 2x plus 1 if x is less than 1, and then 3x minus 2 if x is greater than or equal to 1. Now, when we graph these, let's look at mainly here the border more than anything. So I call this is basically going to give you the border or the conditions of it. So this one for negative 2x plus 1, it only exists if x is less than 1. And then this one is only for values that are greater than or equal to 1. So that 1 is sort of going to act as a border. So we're going to find where x is 1, and I'm going to put me like a little border line. Now the border line's usually pretty necessary. Okay, so I said kind of highlighting was not really necessary. So there's 1. So that's going to be my border. So where x is 1 is going to be sort of that border line. And what will basically happen is that first graph will go on the left side of this line because it's less than 1. And then this graph is going to go on the right side of this line. Now, to kind of help you really see that here, this is where I'm going to color code it for you. Okay, so this 2x plus 1 only happens for x less than 1. So to help me out here, where would values less than 1 be in relation to my red dotted line there on the left side? Okay, so I'm going to do this. I'm going to use my brown pencil color here for this one. So I'm going to color in brown here to the left of my border line. All right, there again, I'm only going to do a couple examples where I color code because it just takes too long. Okay, so we've got left side over here. Now, for x greater than or equal to 1, that would be to the right side of that line, right? Does that make sense? Okay, so here's the thing. I'm going to graph that first one on the left side, and then that second one over here on the right side. Yes? All right, that's my border line. All right, look at the conditions over here. So this graph is for only values of x that are less than 1. And this is for values that are greater than or equal to 1. All right, does it make sense now? So this one's going to be on the left side of 1, and this one's going to be on the right side of 1. So it serves as a boundary. And so what happens is these two shouldn't cross. It's kind of like this. You'll remember in the 10th grade, you'll probably read The Outsiders. All right, you had what? Socials and greasers. Okay, so they had their territory right, and so one never crossed into the other. That's the idea. All right. Now, let's graph these, but we got to keep in mind here that this negative 2x plus 1 can only be in the brown area, and then the 3x minus 2 is only going to be in that blue area. All right. And this is, again, probably why you're going to need a straight edge here. Okay. Let me graph negative 2x plus 1 here first. So let's see. Y'all help me out here. So we would use the y-intercept of 1 first. Okay. So right there. Notice I'm not doing it on that line. I'm still doing it on the y-axis. Now, my slope is negative 2. So I'm going to think of it as negative 2 over 1. So it would be fall 2, run 1. Okay, right there. Now, I'm going to put my straight edge, and I'm going to line those points up. Now, here's the thing. We're doing this graph right here, right? It only exists where x is less than 1. The brown area, right? So I can only draw this line on my brown area, or to the left of my boundary. So when I start drawing, this is okay because I'm in the brown area, but then where am I going to have to stop? Where I hit that line, right? So I can't go past that line, can I? I got to stop it right there. Now, it's going to keep going in that direction. Now, how can we show here it's just less than 1, so I actually really can't touch 1. So how can we show that we can go up to 1 but not touch it or include it? Right? What does a parenthesis sort of represent on a number line graph? You kind of got the right idea. Do a open circle. Does that make sense? Okay. And, you know, like on interval notation, it would be a parenthesis. Okay, so you got the right idea there. All right. So now, notice how that graph only went on the left side of my boundary, because it could only exist where x is less than 1. Now, let's do my other one. 3x minus 2 if x is greater than or equal to 1. All right, so let's do the y-intercept first. So we're going to go down to negative 2. And then what here? Up 3, rise 3, 1, 2, 3, and then run 1. Okay. Now, when I draw this line, I'm going to line my points up here. But we can only draw this line in the blue area, right? We can only draw it where x is greater than or equal to 1. So, am I actually going to see a line through this point right here? No. The only thing this point is helping me do is it's helping me line up my straight edge. Okay? That's only the reason why it's there. So I'm only going to graph it from this point where it hits that line over. Okay? Now let's talk about this endpoint right here. We said this one was open because we didn't include 1. Now this one includes 1. To really show that, we'll use a closed circle. All right, y'all get the idea there? It's kind of like you're taking two equations. One equation gets the left side, one equation gets the right side of that border right there. Okay, let's look at another one. All right, let's try this one. Let's do f of x here equals negative x if x is less than negative 2, and 4.
Attention teachers, at this time we need all members of the band and the color guard to report to the teachers. All members of the band and the color guard report to the gym for pictures. Thank you.
Do what now? I know. All right, I'm videoing it, so you can go back and watch the first example. Yes.
Like this side, you have like A, B, and C.
I'll show you that in a minute. Okay. That's the easy part. Okay, what we did yesterday that you missed. Don't worry about that. You'll be fine there. Now, so let's take a look at this one. So remember, when we first look at these, the focus is more of the border right here. Yeah, we're graphing. Okay. Now, so we can clearly see where's this border going to be at now. -2. All right. So we've got one graph that's less than -2. The other graph is greater than or equal to -2. So, So -2 is what we're going to call our boundary line. Did she show you that okay? Real easy one. Okay. Here's the hard part. It's graphing that's the hard part on piecewise functions. Okay. So let's try to get a big picture idea, and then we'll start graphing it here. All right. So this graph of -x is only if x is less than -2. So describe where would I actually graph that then? To the left. Okay, so we'd only graph to the left side of that borderline, because for this graph it can only be where x is less than -2, which would be in this area. Okay, now this graph, we'll worry about what it looks like in a second, it can only be where x is greater than or equal to -2, which would be on the right side. Okay, now let's color code that. All right, so I'm going to do blue for this one. Okay, so my blue area would just be to the left of -2 over here. Okay, now on the other side, we're going to graph this one, and so that's where x is greater than or equal to -2. So I'm going to do that with my brown there. Okay, so I'm going to go. Okay, now this is just setting it up so I can graph it. Now, there again, it's kind of elementary to color code it, but it helps you to see it like the first couple of examples you see. After this example, unless y'all just really want me to here, I'm not going to color code anymore. It just takes too long. Okay? So now y'all are certainly welcome to get you some highlighters, pencil colors, and do it yourself. Now, let's start graphing. Okay, let's graph -x. All right, how do we do that? Well, remember what y equal x is one of our symmetry lines. Y equal x went through like diagonally through the origin. Remember what -x did? It went diagonally through the origins, but with a negative slope. Okay, now let's just graph it for real here. So what's our y-intercept on that? 0. You started at the origin. Okay, and now the slope, think about it, would be what, -1 over 1, so we would fall 1. Now when I run 1, is that a +1 or -1? Positive, so fall 1, run 1. Okay, now let's get ready to graph, but pay really close attention. This graph can only exist where x is less than -2, which is like the blue region, right? So is the line actually going to go through those 2 points? No. All those 2 points are there for is to help me line my straight edge up. Okay, so I'm going to line my straight edge up, go through those 2 points, but I'm not actually going to draw a line through those 2 points. I can only draw the line where? To the blue part. And the blue part is where x is less than -2. So that would be from here over, right? Okay. Does that make sense? Now, it says x is less than -2, so it actually can't touch -2. So how do we show that it can go up to -2 but really can't touch it? Open circle. Okay, open circle. All right, now let's do the other one. Now on this one, it may be easier to think of it this way, and it might make sense. You know, f of x is the same thing as saying y. So what is the graph of y equal 4 look like in general? It's a horizontal line. Horizontal line that's going to cross the y-axis at 4. Okay, so I'm going to go up to 4. But now, when I graph this 4 here, this horizontal line going through 4, it can only be in the brown area. The areas that are greater than or equal to -2, which is basically the right half of the graph. So when I get my straight edge to draw my horizontal line here, all right, I'm going to start it so I can do it in the brown area, but then where would it have to stop? Would it have to stop there? No, what? Right there, right? So it can only go from here over. You can darken it up a little bit there. Okay. Now, this one it's a greater than or equal to, so I want to show that it includes it, so I would use closed circle. Okay, there's your graph. Okay, the hard part is if people really don't understand the idea of inequalities, this just totally blows their mind. Okay, you have to have a really good understanding of inequalities. Really, it's more about the conditions than anything, isn't it? Okay, the graphing part is just sort of secondary. All right, let me do one more with you. Oh, there's a piece. All right, let's do this one. Nope, that's the one we just did. This one. Okay, so f of x equals x plus 4 if x is less than 2, and then x minus 4 if x is greater than or equal to 2. All right, so let's go ahead and get our boundary idea out of the way. Now this time I'm not going to color code it. Okay, let's see if we can do it without that part. All right, now we're still going to put a boundary in there, though. Okay, you have to have some sort of boundary to help you out there. So the boundary is obviously going to be where? 2. Okay, where x is 2. A lot of the first few problems that you'll do, your boundary will be at 0, which is the y-axis, and that's pretty nice because it makes, you've already got like a line there. Okay, when you have the boundary being at 0, it's just the y-axis divides it. Now, so let's start graphing here. So, and let's think before we graph, the x plus 4 graph, where is it going to go with respect to my boundary line? Right, it's only going to be to the left of that line. And then x minus 4 is only going to be to the right of that line. All right, now let's graph it. So x plus 4, tell me where to go. All right, up 4, my y-intercept, and then my slope would be 1 over 1, so I'd rise 1, run 1. Okay, now, when I draw my line to those 2 points, though, all right, I can't just draw it wherever I want to. It has to be where x is less than 2. So less than 2, this is 2, so it would be only to the left side. All right, that one's just less than 2, so it would be open. Okay. Now let's graph our other one. X minus 4. Now, don't do this. Don't go 4 down from here. Not on your boundary line. Okay, we're still going to go on the y-axis, and we're going to go down 4. All right. Now, what's our slope there? Same thing. 1 over 1. So coincidentally, what's going to happen with these two lines? They have the same slope. They'll be parallel. Okay. Now, all right. When we draw this line, All right, I'm going to line up my 2 points. Right, it's only going to be to the right of my boundary line right there. Okay, so it's not actually going to go through those 2 points, is it? Those 2 points just help me line up my straight edge. So I'm going to go from my boundary line over to the right. All right, and that one's equal to, so then this one would be closed. Okay. Now, I don't have anything written up on today's board. I just didn't get around to it. So what I want you to do on your piecewise function worksheet, do the odds. Okay. And what I'm planning on here is we'll do the odds, do as many odd ones as we can in class, and then come back tomorrow. I'm gonna like really check on you, make sure you're doing these okay, and then we'll do the evens in class tomorrow. Okay. The graph ones. We already did the other ones anyway, so.